So we're going to talk about the rest of the rules sort of for dealing with exponents, and we know most of them already. Just to review though, if I'm going to raise a power to a power, if I'm going to take 3 to the 4th and I want to raise that to the 5th, what do I do here? What do I do when I raise a power to a power? Yeah, we multiply. I always draw this little ring around these two things to remind myself that I'm supposed to multiply those two together. So when I raise a power to a power, so I'm raising a power to a power, we multiply. This is 3 to the 4 times 5, which of course would just be 3 to the 20th, okay? So raising a power to a power would be multiplying. So in general, if I have a raised to the m raised to the nth power, it's just a to the m times n. And that would be our rule for that one. All right, raising a product to a power is a little bit different, right? So let's say I have, a, b, and I want to square this whole thing. Well, the product is a times b, right? That's why the rule is called product, because I'm multiplying a and b. Well, the product to a power, right, means that I'm going to take a and square it and multiply it by a b and square it. So everything inside my parentheses gets squared, that power. This is not the same thing as this, okay? Many students just mess this up. They call this was on our test, right? You guys remember that? What's the difference between these two?
Well, you have to use a squared plus 2ab plus b squared.
Okay, well, can we actually say the word that is the difference between these two things?
Addition and multiplication.
Yeah, one is a product and one is a sum, okay? Notice that the rule is a product to a power, not a sum to a power. So this is not a rule in algebra, all right? But you can see why many algebra students make that mistake. So I'm here today to tell you to not be that student who makes that little mistake, okay? It happens every year, don't we? I'm sure it does. So let's do a little quick example of this one, just to make sure we're on the right back. What if I did 4b all to the 3/2 power? Well, that's a product raised to a power. So this is 4 to the 3/2 power times b to the 3/2 power. Okay? How much is 4 to the 3/2? We just did this problem a little while ago. What did we get from that? Anybody remember? Yeah.
Oh, we got 2 to the 3rd.
We got 2 to the 3rd, which is 8, right? Very good. So this becomes 8b to the 3/2. So that's kind of where we're going with this rule, that product to a power rule. All right, so let's talk about dividing powers of the same base. So if, for example, right, we already talked about this a little bit. So if I take a to the m and I divide it by a to the n, I think, Pallavi, you actually talked about this one. What do we do to the exponents if I have the same base? We subtract them. Very good. So this would be a, right, to the power of m minus n. We subtract them. And we already talked about that a little bit in the previous lessons as to why that works. So as an example, really quick to illustrate the point, if we have 2 raised to the power of 6, all divided by 2 raised to the power of 2, it's just 2 to the power of 6 minus 2. The exponents are being subtracted because I have the same base, which is just 2 to the 4th. And we would be done with that. Or you could take that out and actually simplify it. Okay, last rule, we're talking about raising a quotient all to a power. If I have a over b, notice that a and b are different bases. So if I take a quotient and raise it to a power, what would I get? I would get a to the n divided by b to the n, okay? So I am allowed to raise each base in the numerator and the denominator to the power of n. So as an example, if I have 3/5 and I want to square that, it is 3 squared over 5 squared, which would be 9/25. Okay, so we are allowed to do that as well. All right, how do you guys want to go about doing this? Simplify the directions they want us to do, or just simplify the expression, meaning take all your fractions down to their lowest form, make sure every exponent has is positive. So how do you want to approach it? There's a couple different ways that we could do it.
We just simplify it.
Yes, that's our goal, simplify it. Okay. I would do this. I would break it up into coefficients, A's, B's, and C's. That's how I see things. Yeah, Will.
You could simplify the fraction.
Yep, so let's simplify the fraction. What's 12 over 4? So remember, I'm going to have a big fraction in the end. So that's going to be 3, right? 3 over 1. I have a to the first over a to the negative 5. I'm dividing two exponents with the same base, so that would be subtracting of the exponent. So that'd be negative 1 minus 6. How much is that worth? Oh, sorry, negative 1. I gave you the answer. Negative 1 minus 5. How much would that be? Negative 6. But I can't have it as a negative exponent, right? Well, where would that be, by the way? On the bottom, right? So what do I do?
No, move it down.
No, you move it up, so it'll be 8, 6, 8.
Okay, so let's approach this. Let's do it this way then. So I know 12. I'm gonna have 3. Then I'm gonna have a to the negative 6. Then I'm gonna have b to the what? B to the positive 7th, and then finally c to the what? Negative 8. Okay, if you write it out this way, now you can see which ones are supposed to be on the top and which ones are supposed to be on the bottom. I thought we could maybe skip this step. That's actually a good idea to not skip this step. Okay, so now of these exponents, I can see that a to the 6th is negative and c to the negative 8th is also negative. So I'm going to rewrite this, and the final answer of 3 b to the 7th over a to the 6th c to the 8th. And that would